nth root theorem. If n is any positive integer, r is a positive real number, and theta is in degrees, then the non-zero complex number r cosine theta plus I sine theta has exactly n distinct nth roots, given by the following. So the nth root of r times the cosine of alpha plus I sine alpha, or the nth root of r cis alpha, where alpha is theta plus 360k over n, and k is 0 through n minus 1. If in radians, then alpha equals theta plus 2 pi k over n. So we're just going to take a look at this problem here. It says find all the cube roots of the complex number for I. So we're looking for cube roots of this. So what we're going to do first is turn it into this form here. So right away we see that we have 0 squared plus 4 squared equals r squared. Remember, my a here is 0 since I don't have a real part. So this is going to be 16 equals r squared. So r equals 4. Okay, now from here we need to find the cis theta. Essentially, I have to know where I'm at on my graph. Now remember, 4i is 1, 2, 3, 4. It would be here. So just kind of remember that. And I know that degree is 90 degrees. So that's where that 4i would be. So now I have all I need to get my nth root of r cis alpha. So then this results in 4i equaling 4 cosine 90 degrees plus I sine 90 degrees. So this implies r cubed cosine 3 alpha plus I sine 3 alpha actually equals plus I sine 90 degrees. So then that implies 3 alpha equals 90 degrees plus 360k, because I want to think of all the possibilities here. All the angles that are 90 degrees. So now we're going to take and divide by 3. So I'm going to divide everything by 3. So then alpha is going to equal 30 degrees plus 120 degrees k. So where k equals 0, alpha is going to equal 30 degrees. Where k equals 1, alpha is going to equal 150 degrees. And where k equals 2, alpha is going to equal 270 degrees. So now we can plug all those in and get the complex numbers. So my r is still 4, and now I have my alpha being 270. So that's going to give us 4, parenthesis, cosine of 30 degrees plus I sine of 30 degrees. That's one of them. The next one is 4 cosine of 150 degrees plus I sine 150 degrees. Okay, and the last one is going to be 4 cosine 270 degrees plus I sine 70 degrees of sine. So those are our three answers that we're looking for this one. It said find them all, and we're looking for the cube root, so that means there's going to be 3 of them, and that's what we see. So let's try another. All right, take a look at this one here. Nothing changes. I'm going to first turn it into the polar form of the complex number. So the first thing I need is r. So that's going to be 1 squared plus square root of 3 squared equals r squared. And I'm going to get r equals 2 once I simplify. So that's the first thing I need. Now I'm going to need theta. So this one's one of the triangles we know, so I'm just going to set it up this way. So 1 down here. I could just do the tan inverse, and that's okay, but this one works good for me. Negative square root of 3. This is 1, so that's 2. So then this angle then is 60 degrees. Or I can say 300 degrees. Or honestly, not 60 degrees, but negative 60 for the actual angle. So I think I'll use the negative 60 because it really doesn't matter with that one. Okay, so my r, my complex number then in polar form is going to be 2 parentheses cosine of negative 60 degrees plus I sine negative 60 degrees. There. And remember here, we still want the cube root of this. So what that means is that this is going to equal, I forgot one thing on the previous problem. It just hit me. This here should have not been the 4 here, but it should have been the cube root of 4. That's what I should have had there. So I apologize for that, but that's that answer. Let's go back to this one now. So then when I look at this one here, this is my complex number here. So this is actually equal to this over here. All right, so now what we're going to do is we're going to use our handy dandy formula. So that means r cubed cosine 3 alpha plus I sine 3 alpha equals what we see on the left here. So now that's why we're going to have for r, we're going to have a cube root of 2. So I forgot that piece. Okay, I remember it now, but okay, so I have that 3 alpha there. So now that tells me 3 alpha equals negative 60 plus 360k. So I'm going to take that divided by 3. So then my alpha is going to equal negative 20 degrees plus 120 degrees k. Oops, I divided it, so I don't need the bottom now. Okay, so that would be my angles. So then for k equals 1, we're going to get, or I should say k equals 0. Okay, so k equals 0, we're going to get alpha equaling negative 20 degrees. K equals 1, we're going to get 100 alpha equaling 100 degrees. And then for k equals 2, we're going to get 240, 220 alpha equaling, alpha equaling 220. So those are our answers that we're going to use to plug into our cis theta, excuse me. All right, so here we go. So my answers then are cube root of 2, comma, cosine negative 20 degrees plus I sine negative 20 degrees. And then the second one is going to be cube root of 2. And then this is going to be cosine of 100 degrees, plus I sine 100 degrees. And then the last one's going to be cube root of 2, cosine of 220 degrees, plus I sine 220 degrees. So there's our three answers. Okay, I have one more I want to do here. Now, honestly, this one's no different. My idea here, or not my idea, but the idea here is I'm just going to move the 1 over here. And really, it's asking the exact same question in the same work that I did for the previous problems. So for what complex number to the 5th power equals I? And that means I'm going to find the 5th root. Okay, so in the process of that, I'm going to use the same ideas I did for the previous problem. So then what complex number equals I? So I here is going to equal, and my radius there is 1, so I'm going to put a 1 here. And this is going to be cosine of 90 degrees plus I sine 90 degrees. Just think about it. I would be up here. Okay, so anyways, so now there is my my quality there in terms of the polar form. So now I know that this has to equal r to the 5th cosine 5 alpha plus I sine 5 alpha. There we go. So really what we're looking at here is 5 alpha equals 90 degrees plus 360K. So when I divide all this by 5, okay, my alpha is going to equal, I get 18 degrees plus 72 degrees K. So now from this formula, I can get all of my other angles. Now I need 5 of them here. So for K equals 0, we're going to get alpha to equal 18 degrees. Or K equals 1, we're going to get alpha to equal 90 degrees. Or K equals 2, we're going to get alpha to equal 162 degrees. K equals 3, my alpha is going to equal 234 degrees. And then K equals 4, my alpha is going to equal 306 degrees, and that's the last one. So those are going to be our alphas here. It's going to be our angle measures. So all we're going to do now is plug them in. Now for this one, since it's I, it is a radius of 1, so we don't have to worry about that 5th root of the r there, because that's just going to result in 1. So it's really just going to be 1, and then I'm going to write cosine of 18 degrees plus I sine 18 degrees. There's the first one. The second one is going to be cosine of 90 degrees plus I sine 90 degrees. And the next one, I can have a 1 in front of there. Okay, next one's going to be cosine of 162 degrees plus I sine of 162 degrees. Then the next one is going to be 1 cosine of 234 degrees plus I sine 234 degrees. Okay, now the last one, we had a fifth one there, that's only 4. It's going to be 1 cosine of 306 degrees plus I sine 306 degrees. So those are all of the 5 answers there that we're looking for this problem. So it would be these. All right, done.